Hello, everyone. My name is Kynan, and I am here to present work that I've done with Dr. Matthew Gusdile at the University of Alberta. And what we've done is we've worked on generating real-time strategy game units using Search-Based PCG and Monte Carlo Tree Search. So, little intro on RTS for any who may be unfamiliar. It's a genre of games in which both players who are playing are doing everything at the exact same time, managing their resources, building an army, and fighting simultaneously, as opposed to turn-based. Some examples are StarCraft 2, Warcraft 3, and Age of Empires 2, just to name a few examples. But one common thing amongst all these games is the issue of keeping the game units balanced, keeping them fun and balanced so that players enjoy the game rather than going to Reddit and complaining. So some examples of this from StarCraft 2 would be the carrier. It has been modified since 2015 a total of 10 times. And to give some reference, balance updates only happen about 2 to max 3 times a year. It's only 3, maybe 4 units being touched at a time. And another even greater example would be the Zerg Infestor, which has been modified since 2010, a total of 20 times. So obviously, a lot of changes have been needed to keep the game interesting and fun. So we decided that we wanted to try and see if we could use PCG to be able to generate units in a game that could be balanced rather than having the whole long multi-year process of trying to do it by hand. So our goal was to use PCG to generate units that were unique from the other units in the game, but remained balanced. And we looked at if there had anything been done before this, and there hadn't. So we decided to go and try and create a process ourselves. So the first thing we had to do was come up with a game to use it in. And we found one called microRTS. And it's a very small game developed by Santiago Antonin that is designed to be a test bed for AI research. And in it, you have an 8x8 grid in which you have workers that go and mine resources in the corners. And then you have the ability to build 3 different units, the light melee unit, heavy melee, light ranged. And we added a 4th, our generated unit. And I have a short little demo of how the game is played. So in it, you see both players start and they're building workers and army units, going and collecting resources. And once units start to pop out, they go and start to make their way across the map, attack each other. And the goal of the game is to try and kill all your opponent's units and buildings before they do that to you. And as the game goes on, different things happen. And now we're reaching kind of the end point of the game. It's a relatively fast game. And now these 3 units are just going to run around and try and kill the others while not dying themselves. And either one will succeed or the timer will hit a maximum and the game will end in a tie. So we decided this would work great for our purposes, because looking back at the old work, since nothing had been done, we didn't want to jump to some huge game. So we wanted to build off things like boss generation that designed bosses that had different stats for players to fight. And in RTS, we could find things like map generation. The one example here we have shows a game called Planet Wars, I believe it's called. But it's also been done in StarCraft Brood War. But nothing really revolving units in RTS. So we developed our own approach, our own process to this. And this is kind of our high level look at it, where we'd start by generating a unit, creating a list of neighbors, putting it through an evaluator, choosing the best one, and repeating that process all the way until we find a local minimum, a local maximum, where none of the neighbors could outperform it. And to go in a bit more depth on this, our search space to generate an initial unit, we defined by picking only certain stats that a unit could have in microRTS. There are more than what we've displayed here, but these were the ones we felt were important to create a unit that was unique and could impact the game in different ways than other units. We also added another element that the game didn't have, and that's unit abilities. In a lot of other RTS games, you'll see different units with different spells or traits, and that wasn't really present in this game. So we added some of our own, and we split it into 2 categories, where the ability would have a cause, something that would trigger it, and that would be whether the unit dies, takes damage, and all the details of that are in our paper. And once the ability was triggered by one of these causes, a specific effect would happen, such as returning the resources that were used to make the unit, doing extra damage, healing. And the interactions between the causes and effects were slightly different depending on which ones matched up. And again, the details are in our paper. So once the initial unit was generated with the stats randomized, we had to see if we could figure out how to improve it. So we'd first generate that unit, create the list of neighbors. Then we'd send it into the game and use Monte Carlo Tree Search agents to test these different units to see which one could potentially perform the best. And then based off of that, it would pick the best one, send it back, create a new list of neighbors, and repeat until ultimately a champion is crowned. From there, we would, pardon me, the way that they would be evaluated in that test arena was that we'd have 2 Monte Carlo Tree Search bots that would play with the units over the course of 2 rounds. The first round would consist of only 1 bot being able to make the new unit, which would help us see the utility of it. Is this unit powerful? Is it useful? Does it help the player win? And the second round, allowing both bots to make it so that we could see, does the game still remain balanced once it's there? So to be able to see if this method would work, we created a set of experiments. So first was just to check novelty, to generate units, to see if they would be different and have unique qualities. The second test was to determine the utility of the unit, kind of like in our generation process, but to a greater extent. And the third, to test the balance, again, to a greater extent, like with utility. So the first of our experiments, once we got our code to work, we had some tests where we try and generate a unit, see if it would work. But once we could confirm that it worked, we generated 10 units. And these were the first ones that we generated. The first 10, we didn't cherry pick anything. And I'm not going to go into detail about all of these different ones, but I do want to highlight a couple of ones that I personally think were especially neat. The first one being the Phoenix. We gave them each names. And the Phoenix, it had the highest fitness score of any of the units generated. And the neat things about its stats were it had really low HP relative to the other units, but a high damage output. It had the slowest movement speed of any other unit, but an incredibly fast attack speed, allowing it to, it's easy to catch, but it'll kill you before you can hit it, sort of thing. And the ability that it ended up with was when it died, it would return the resources used to build it, thus allowing you to make it again or be reborn from the ashes. The other unit that I wanted to highlight was the Barrage unit. It had a really high HP, the longest range of any unit generated, and a fast attack speed. With the bonus ability of every 3 attacks, it would do a second attack. It would do 2 at once, allowing it to last a long time and kill everything from a long range, sending out a barrage of attacks. So from this, we found that we could generate unique units, but what was left to figure out was, would they have good utility in an actual game, and would they be balanced? So our approach to figuring this out comes from a method given by Zook et al., in which they used a series of different strength Monte Carlo Tree Search agents ranging from weak to moderate to strong, where they'd be playing in a game and using specific strategies in the games in this paper, which were Scrabble and Cardonomicon, in which using these strategies, they'd see how effective the strategy was in these different scenarios, where could a weak agent outperform a stronger agent if it was using a better strategy. So we applied that to our work by creating 3 different MCTS agents of different skill level and allowing them to play each other in the game in 2 rounds where only one would have the new unit, would have the ability to make the new unit, and the second round where they both would. And in this time, we'd have each matchup occur with each unit that we generated, and there'd be 100 games for each matchup with each unit, resulting in 1,000 games between weak versus strong, strong versus strong in each scenario. And so for our first one in judging utility, in this one, we want player 1, who has the ability to make the new unit, be able to beat player 2 who can't more often, because we think that if the unit's useful, it'll help the player win more. And in this example, in nearly every scenario, we found that it worked. Blue represented like pure blue square would represent a 100% win rate, and a pure red square would represent 0% win rate. So here we have the win percentages with their standard deviations. And we found that in nearly every case, having the new units gave a distinct advantage. In one area in particular, we found this was in the weak versus strong, where the weak agent had the new units, the strong did not. It allowed the weak unit to win well over 50% of the time, which was a great indicator. Hey, these units work, they're useful. One interesting area that didn't quite match the expectations was strong versus strong, medium versus medium. We did find that the way that these agents differed from each other was the stronger it was, the less likely it seemed to make the new units. And as the weaker it got, it had more tendency to. And we attribute that to the evaluation functions. The strongest agent had the deepest tree depth of searching and the longest iteration time to search. And the evaluation functions were designed for the original game. So we found that strong agents tended to try and play the original game more. And so in some cases, they just didn't want to make it as much. Also, make the new units as much. Also, some of the units we generated performed better than others with different skilled units, with different skilled agents. The strong was better with other units, and would have a lower win percentage with certain units, whereas weak would have a higher win percentage with the units that the strong agent had a low one in. It was very interesting. But ultimately, our trend followed what we wanted, what we were looking for. In balance, we expected all the matchups to move closer to an even win rate when agents were balanced and move in the direction of the stronger agent was going to have a better win rate. And in every matchup, it moved in the correct direction. We found that things evened up a bit more, and places where there was an advantage were removed. An interesting event that occurred, though, was that the weak versus strong still didn't drop as much as we thought. And again, we think that that's because the weak was more willing to make the new units more often. And while that may seem a concern, it actually falls in line with some principles in RTS games where there are different units are more advantageous with different skilled players. Some units are really bad with low-level players, and some are really, but will be an incredibly powerful unit with a strong skilled player, and vice versa. It all depends on what strengths your opponent has. So seeing that different units provide different advantages based off of the skill of the agent was a very positive sign for us. Our takeaways from this, we're the first people to try and create balanced RTS unit generation, and we think that our method can do that. It is It can produce units that seem to be balanced and that are unique, and so is a positive direction in furthering the work in this underexplored area. And we encourage people to continue to explore this area and find new ways to apply it to bigger games and in new ways. Thank you so much for your time. This is my contact information. I'm happy to take any questions now or later.